So I've been pretty busy since my last video, which was, I don't know, a month ago, probably. And what I've been working on in that time is, well, a little bit of everything, really, but the biggest change was probably a big NPC rework I did. You see, I'm making a game called Ghost of the Zone inside of Sandbox, which is a Garry's Mod spiritual successor made by Facepunch. The game is planned to be a combination of my favorite aspects from Daisy, Stalker, and Tarkov. And since my last video, Facepunch has added support for something called prefabs into Sandbox. What's a prefab? Well, I'm glad you asked the conveniently inquisitive voices inside my head. They're essentially a way for me to create an object, be it an NPC, a gun, or any other combination of objects, and save that configuration of objects in a convenient way for me to create in-game later. Previously, NPCs were a horribly handled mess of data and hard-coded values, and overall just a big pain in the ass to edit and set up. So I spent a good amount of time converting NPCs to this fancy new prefab system, which gives me this lovely little object right here. This is super convenient. Prefabs like this are a great way for me to easily edit the properties of NPCs quickly and have them update in real time. I can also just drag and drop them out of the asset browser in order to quickly test them, which is just a lovely little addition. It took a while to convert every NPC to the prefab system, but by the time I was done, the whole thing was a lot nicer overall. But it got me thinking, was there anything else that I could convert to prefabs while I was at it? So I went ahead and converted my projectile system to use prefabs instead. It makes it very easy to define what a gun fires and what a throwable item actually throws. For instance, I can make this AK shoot grenades, or shoot rockets, or snorks. From the code's perspective, all of these are just prefabs now, meaning the whole system is super modular. Definitely a big improvement. I also went ahead and converted anomalies to prefabs, because figured I might as well. I'll probably convert some guns over to prefabs at some point, but that's going to be a pain in the ass, so I'll save that sorrow for later.
I've spent so much time working with NPCs over this last few months, and I was thinking about you know, burras, right? Like burras are they're telekinetic. They could throw you and you go wee. Okay, but what if a burra showed up and you're just like, oh hey little guy, and then they're like
Anyway, once I had finished converting all these NPCs over to the prefab system, I was messing around and having some fun spawning them in when I noticed the performance was tanking pretty hard once I got around 60 of them in game at once. Anything beyond that and the game would fairly quickly devolve into a recently released AAA game. After a little bit of digging, I found this was mostly due to two features NPCs had. One, NPCs needed to reconstruct their pathfinding when their targets move. So if the target moves by even one unit, the NPC would reconstruct their path to the target. This was usually the player, which means they were moving a lot. This meant if there were 60 NPCs targeting you, and every single tick, they'd all reconstruct their path, and the game ticks at 60 ticks per second. So every second, you'd have 60 NPCs making 60 updates to their behavior. So an easy peasy 3,600 updates every second to reconstruct paths. This was, as you could imagine, pretty fucking abysmal for performance. And the second big issue was that NPCs would check for obstructions around them every tick. This is, of course, not great. It causes a ton of lag when NPCs get grouped up, because you have each NPC iterating over each other NPC near them. So you have 40 NPCs bunched up and you end up with several thousand iterations every tick with a bunch of math and shit to avoid collisions. Not great. Not sure how to fix it right now. I'm just gonna disable it. Call it a day. Now to fix number one, I considered several options, but ultimately settled on two improvements. The biggest improvement to this system was in changing how NPCs are updated each tick. Previously, NPCs were doing their full behavior updates every single tick. And with this change, what I've done is I've split the NPC behaviors into two types, constant and periodic. Constant behaviors are things that need to be calculated every tick in order for NPCs to look and behave as you'd expect. For instance, updating their position and movement every tick. Basically anything that needs to be updated as soon as possible. Now, periodic behaviors are different. These are the things the NPC doesn't really need to be checking constantly. And conveniently, this is also what most of the behaviors NPCs have are. Everything from attacking, to selecting targets, to calculating movement paths, etc. These only really need to be updated maybe once per second at most for each NPC. So the way I've handled this is I keep a queue of all NPCs that are alive, and every tick I go through 10 of them performing the periodic update for that NPC. Once the queue is empty, we refill it with every NPC that is alive continue. This means that some ticks, no NPCs are updated with their periodic behaviors, but they'll continue moving because they're still updated for their constant behaviors. Now what this does is it leads to a huge improvement on the NPC bottleneck, as it prevents every NPC updating everything about themselves every tick. As for the second improvement, I made it so NPCs scale the accuracy of their path path to the target alongside the distance to their target. So essentially, the further away the NPC is from its target, the further the target has to move from the original position in which the path was calculated before the NPC will create a new path. If an NPC is 1,000 meters away from the player, we don't need to recalculate the path it has to the player until it's getting fairly close, or the player has moved a significant distance away from its original destination. This is because from the player's perspective, it doesn't really make a big difference to how the NPC appears to navigate towards them, but it saves a ton of performance on the back end. If an NPC is running at you from 1,000 meters away, you're not going to notice if it doesn't recalculate the path once you've moved like 2 meters. So we can kind of sneakily not do that until we really need to, and it looks fine. Combining these two improvements and optimizing the NPC path generation allow me to run about 150 NPCs with a stable 60 FPS, and that's pretty good. It probably still needs some more work in order to support lots of players on the server. I think that's going to be the biggest issue I foresee in the future, but you know, we'll worry about that later. With NPC performance working more how I'd like, I started work on implementing some NPC spawning systems, a way for NPCs to appear on the map as players are out exploring. The first thing I wanted to do was add a sort of event system, a way for events to happen to players in a semi-consistent way. So I wrote up a quick event system that runs for each player on the server. Every player is assigned an intensity score, and this score dictates the type of events that these players can have, as well as how intense those events are. The idea being that the server can keep an eye on what's happening to you, tracking things like PvP and PvE encounters. Using this, it can adjust your intensity so that you experience big peaks of intensity every now and then. It's pretty experimental, and honestly I have no idea if it's even going to work in the game, but new events are really easy to create and can be anything from spawning NPCs for the player to fight, or airdrops being called into the map. There isn't any really fixed thing that these events have to be, so I'm open to suggestions if you've got any. I was inspired to implement this because of sporadic anomalies from the Stalker games. I haven't implemented these anomalies yet as events, but this is a good example of a low intensity event. Another system I was working on was the region system. The idea being you designate a region in the Hammer editor and you can assign details to the region. For instance, you can choose spawn tables that the region should use during the day, as well as a separate spawn table for nighttime. You can also spawn a global region that represents the whole map, and that global region can have sub-regions inside that. For instance, you can have a sort of general spawn table for mutants that you can encounter on the map, with a more specific spawn table for different regions and areas, such as underground labs or buildings or sewers. These regions can handle spawning mutants and have cooldowns, as well as a bunch of other options you can customize, such as the maximum number of mutants and how frequently they should spawn them. They try to spawn the NPCs out of sight. I feel like it makes it a bit more dynamic. Now I know the question burns in your mind. How do you find a point that's out of line of sight of the player? Well, it's simple. You just have to have a massive brain. The region randomly picks a point within a certain range of the player that's inside the region, and then checks if that's in line of sight. If it is in line of sight of the player, we wait until the next tick before trying again. Otherwise, we spawn a creature. I call this BOGO spawning, because it's probably what a professionally licensed clown would make if they were to write this. I considered some alternatives, but frankly, this works, and it is actually quite performant because I limited how many times it can try each tick, and it looks good from the player's side, so fuck it. With all that shit done, that's all the NPC work I've gotten done recently, so it's time to move on to inventory work. My favorite. Continuing my work on the inventory system, something I really wanted to improve was the way items were serialized and sent between server and client. The way this used to work, items on the client could only ever be the base item class, but items on the server could be whatever item type they wanted, such as weapon items or armor items or ammo items. This was fine while I was creating the inventory system, and it helped me figure out how to get the whole inventory system to be item type agnostic for the most part, in that it'll display everything without really caring what type of item it is. However, now I wanted items on the client to represent their real item type as well. So I had to go about basically rewriting the item serialization. Thankfully, I was inspired by one of Facepunch's projects, which are mostly all open source and you can just go take a look at, which is nice. So I yoinked a bit of code out of here and there, and once that was done, I had the correct item types on the client as well. And the first thing I wanted to do with this new system was implement proper ammunition for guns. That is, guns would take ammo out of your inventory when you reloaded them, and required ammo to be fired. Previously, guns didn't rely on you having any actual ammo in your inventory, so this was a pretty big change. It took a lot of work to ensure that all the predictions still worked for reloading. That way it still feels seamless on the client regardless of what your ping is. Now once you start reloading your gun, you see a little lock pop up on your inventory, and your gun and the ammo it's loading get marked as busy, and it starts flashing. Once the reload is complete, the ammo is removed from your inventory and loaded into the gun. Now what's cool about this is it makes implementing unique ammo types incredibly easy. All the data used for firing bullets is stored on the ammo item, so different ammo types is now super easy to implement. For instance, I can load this gun with regular 5.56 ammo or some super special 5.56 ammo. This also means that damage that each gun does is now tied to the bullet rather than the gun. The big difference that makes is that if you find a gun that is the same caliber as another gun, it will do the same damage. Mostly the way weapons scale is how quickly they deliver that damage. For instance, low tier weapons would be things like bolt action rifles versus someone with like an SKS or, like an anti-material rifle. It's just the caliber of the round and how quickly you deliver that round to whatever you're aiming at. Something else I wanted to do while working on this system was be able to drag ammo onto your gun to reload it. And this was pretty simple, and I whipped up some lovely UI codes. So when you start moving an item, it highlights everything you can combine it with. However, and I quickly realized this was dumb when you could open your inventory, drag the ammo onto your gun, and have your weapon reloaded far faster than if you had just reloaded it normally. So how do we fix that? I figured I could implement a timer system for inventory actions, or instead I could hack together the weapon reloading I already had working in order to make something far less reliable and harder to maintain. So yeah. Now when you drag your ammo onto a gun in your inventory, it queues a bunch of actions that take place in a sequence. It draws the gun, starts reloading it, and holsters it when you finish reloading. You can cancel this sequence at any point, but you can't use the gun you're reloading unless it's in one of your equipment slots. It's a pretty neat system, and it gave me an excuse to create an action queue, which is useful for a bunch of stuff. This queue system allows you to essentially queue actions the player is going to take. For instance, it allows me to now, when the player wants to drop a weapon they're holding, it first plays the holster animation before actually dropping the gun. And it seems simple, and it is really, but it helps with abstracting away all the types of actions a player can take. I wanted to add ammo for guns, and ended up having to rewrite a fairly huge portion of the item serialization, weapon code, and how the player interacts with themselves. Call that game development, baby. Side note, while I was doing this, I also went ahead and cleaned up my code base. I separated a bunch of shit into partial files, and so now it all looks lovely and spread out with obvious file names. This kind of thing isn't 100% necessary when you write a lot of code, but it makes it very easy to find what you're looking for, and keeps things separate and nicely boxed off from each other. If you see a single file approaching 500 lines, maybe you should start thinking about making your own partial classes. Now that I finally have that crap out of the way, I wanted to implement consumable items, things like bread, water, medkits, bandages, etc. So the first thing I had to create was a consumable item type, give them a couple stats for how they work, and then go to town on actually creating some. However, with consumables, there was one feature in particular I was keen to implement, and that is when you right-click an item, I wanted it to bring up a menu of actions you can take with that item. Pretty standard stuff as far as inventories go. The way I envisioned it was I wanted adding unique actions to different item types to be as easy as possible, and I came up with a solution that leaves me feeling like I've done something wrong, but it works. So I added an attribute that you can add to a method in the item's code that marks that method as an item action. What then happens is on the inventory screen, when you right-click an item, it creates a little action panel with all the available actions that are marked in the item's code. It does this by using reflection in C# to look at all the methods on an item with the attribute and then compiling a list of them for the client. So in order for a new option to pop up, all I have to do is add an attribute to a new method. Then when the client clicks on an option, it sends a request to the server to do the specified actions. Is this a good system? I have no idea. I'll find out when I make more things use it. I'm definitely thinking of trying something else later, but for now, it's done everything I needed it to, and I'm pretty happy with it. For instance, it's you can now drop items. Pretty neat. Now that this system was implemented, I could add a use action for consumable items. This was also pretty simple. We just mark a method like I said, and remove the consumable after use, and bam, we've got consumables working. The only problem is there's nothing for consumables to interact with, so we need to create some sort of stat system for the player. Now, of course, things can never be easy. So the way I went about this is creating an enum of stat values that I want the player to keep track of, including all your resistances, your health values, your stamina data, etc. These are all the stats that the player wants to be able to modify during gameplay. Then Then we store a networked dictionary of float values using the same stat enums as the key for the dictionary. We then create a second non-network dictionary that also uses the stat enums as a key, but this time we use a custom class called stat value instead of a float for the value in the dictionary. This second dictionary is where we store the real data for the player's stats. The stat value class allows us to apply modifiers to a base float, such as addition and additive multiplication, as well as unapplying those modifiers, while always remaining sure of what the base value of that stat is. Then we make it so that after each update to the stat value in the internal dictionary, we make sure to update the networked value with our new modified stat. With that all working, we then just initialize all our base stats on the player when they spawn. And what's cool about this system is it lets me abstract away creating stat modifiers for the player. So for instance, on our consumables, what I did is create a new resource called a status effect. And what this will do is hold some data about a status effect that can be applied to the player. We can specify the type of stat we want to modify, and we can specify what kind of math we want to apply to it, whether we should add a flat value or additively multiply the value. We can also give it a duration, and it allows it to automatically remove itself. You can also specify an icon and a color for the status effect, which will appear on your HUD when the effect is applied. So essentially, what this does is let us fire and forget status effects. We can just make a custom effect, say we want to apply a 20% increase to the player's movement speed for 10 seconds. Done. We just create a little stats modifier, we add in move speed, 50% multiplier, or 0.5, make it additive, and call it a day. Then, after 10 seconds, the stat system will automatically remove our status effect. Anyway, we're doing all this for our consumable items. So once we have our status effects ready, we create a list of them on the consumable item, and we let you just drag and drop different status effects onto the item. So we can make this booster that gives the player a speed boost, while also giving them negative health regen, meaning they take damage over time. Or we can add bread, which restores hunger, but drains a little bit of thirst when eaten. This kind of modular stat system is incredibly useful as it allows you to very quickly create new modifiers and stat types. It also allows add-ons to very easily add their own consumables with special effects. Kind of skipped over it a little bit too, but I used that action queue system from earlier to create a temporary weapon that is used for consumables that have an animation attached. These are also taken from Stalker Gunslinger with permission. Much love. Very happy with the overall shape of this system. It turned out very flexible and easy to use. There's probably some more tweaks I can make to allow it to be even more flexible, but this is certainly enough for now. Holy moly, that is a lot of inventory work, but we're not quite done. Last thing I wanted to cover is working with a randomly spawning loot system. My initial plan for this was to create a resource that you would create spawn lists with. These would be created by manually selecting items that would then be put into a spawn list, and each item would be assigned a weight. It quickly became apparent that this wasn't going to work. Adding items took ages, and the menu started getting really bloated. It also wasn't very friendly towards add-ons and mods. It would be difficult for an add-on to add new items to the loot tables without some weird hackery. I was pondering how to fix this when I stumbled upon a devlog from the creator of Road to Vostok. I thought their overall loot system architecture was fantastic, so I went about implementing my own take on their idea. Big credit to them, because this is definitely not my idea. In my implementation, there are 5 categories of loot: military, civilian, scientist, stalker, and anomaly, and you can assign any item to any number of these categories. Each item also has a rarity associated with each of the categories they're in. For instance, a pistol can be included in the civilian item pool as a rare item, while being a common item in the military item pool. Each item is also assigned an item category, such as a weapon or food, which can also be used to narrow down results when spawning items in randomly. Loot containers and loot spawners can then specify what item pools they should use. For instance, military containers spawn military gear, science labs spawn scientist gear and civilian gear, and maybe some military gear. What this means is that each item is responsible for adding itself to the loot pool, which is great because it means that add-ons that add new items to the game can easily add themselves to the loot pool with little to no friction. It's definitely going to take some time to iron out the issues with this and adjust numbers so that it feels good, but I'm much more confident in this than the first iteration I had. Alright, one final thing related to the inventory system. I've added some player conditions like thirst, hunger, radiation, bleeding. These are similar to stats, but they don't use the stat modifier system. Instead, they're hard-coded onto the player, which is maybe better. I'm not entirely sure. I'll decide later. You can see how severe each of your conditions is by the icons on the left of your screen. If they're not a problem, they're hidden. If they're approaching problematic levels, they appear as white. If they're yellow, they should be addressed immediately, and if they're red, they're at extreme danger levels. I'm not entirely happy with how these look, but it's definitely good enough for the time being. Also, I've added bleeding back to the game, and I've added some VFX for it. It's kind of placeholdery, but honestly, it looks fine. Now, whenever an enemy hits you, there's a chance you start bleeding, and you can remove the bleeding by using a bandage or a medkit, or just waiting it out. Bandages will heal bleeding much faster than anything else, so you should always keep a couple on you. There's also a temperature condition, which I'm not 100% sure I want to implement, but it adds a lot of depth to things like thermal anomalies and weather. Your temperature thresholds, basically how low and how high your temperature can be before you start suffering negative effects, would be modified by things like your armor and artifacts you're carrying and whatnot, so you might need specific gear to explore certain areas on the map, which sounds pretty cool to me. Anyway, I sometimes ask people to vote on features I'm unsure about on my Discord server, so come and join me if you'd like to be a part in the discussion. Link in the description below. I also have a Patreon, patreon.com/fortunedev. I want to work on this kind of thing full time, and if you want to support me, feel free to check it out. Alright, now that we're done with the inventory stuff, what else have I been up to? Well, one of the Facepunch devs was working on their survival game mode and implemented a day-night cycle, which, yoink. I wanted to try making a big open map in Sandbox, which is something the engine currently struggles with a bit at the moment, but it was a good excuse to use this new day-night cycle. So I opened up Blender, installed some terrain generation software, and went about figuring out how that works. After a bunch of trial and error, I got a mesh that I thought looked pretty good. I had to be pretty conservative with how many triangles it had, otherwise Sandbox would lag while I was adjusting it in the editor. Once that was done, I imported that mesh into a new map in Hammer, scaled it to fit the Hammer grid, and hit compile. Not much to look at the moment, but we'll get there. Next thing to do was apply some textures, set up a skybox, and now it looks vaguely like a real map. So I spent some time writing a custom tree shader. This way I could get some nice tree sway and leaf movement, and then I bought a pine tree asset pack and imported all of that into Sandbox. With the new trees and the new shader, the map is actually starting to look pretty good. My shader though was pretty limited. It really only looked good on these specific kinds of trees, and not long after I implemented it, Facepunch went ahead and added their own official foliage shader. Still though, I learned a lot making it, so it wasn't a whole waste. With trees on the map and a skybox setup, I added a big central road and some power poles to the map. Testing the day-night cycle, it looked okay, however I noticed some problems pretty quickly. Source 2 isn't really built for full global illumination and real-time lighting. It's designed for pre-computed lighting using a system called VRAD, so it was struggling a bit with things like shadows on this big map. There's currently no skybox shader that can handle changing during the day-night cycle, so that's something I'll have to create a custom solution for. As a result, I think I'm going to have to leave it for now, but it looks cool, and it's nice that it works at all. The team at Facepunch have said they're interested in improving things like global illumination and real-time dynamic lighting, so hopefully it'll look even better in the future. The current thing I'm working on is adding points of interest to this map so that there's an actual game to play. It takes me ages because I'm not a good map designer or even a great level designer, and hopefully we'll get there in the end. I also need to work on making the map a little more Eastern Europe depressing and more overcast and drab, something more in line with the Stalker games. Next time I see you, we'll have a real game after nearly 2 years of working on this, and if you've made it this far, thank you so much for watching, and I am sorry for the long delay between videos. I'm truly incapable of following a schedule, it seems. The last couple months have been quite challenging on my mental health, and sort of a vicious cycle of not uploading and then feeling bad for not uploading, and so I'm sorry for not delivering content and being slow on updates. Even after all this time, I still am dedicated to this project, and I'm really glad that people have stuck it out this long. So thank you. It really means a lot to me.